Hello everyone, hope everyone's doing well. So today we're going to be going over some QMS 110 material. More specifically, it's going to be on chapter 4, and we're going to learn how to solve a 3-variable, 3-equation system using elimination. So I've left the 3 equations on the left side of your screen, and I would encourage you to take a look at them, give, let's say, about 5-10 minutes at least, really try to understand where you're standing in the beginning of this video, and then I will ask you to try to solve the problem one more time about in the middle, and then at the end I will give you some more exercise questions you can practice on. So go ahead and pause the video now. So hopefully you've done that, and with that out of the way, let's get to some review. So earlier on in the chapter, we learned how to solve 2-variable, 2-equation systems using the very same method, elimination. So we have a more in-depth video on that on the YouTube channel. So if you don't feel comfortable with that or just want a more in-depth review, I would definitely recommend you to go ahead and check that video out. It should be in the description. But other than that, I'm just going to go over it very briefly, just so we have some background going into the 3-variable, 3-equation questions. So the main idea with this is to make the coefficient of one variable opposites and then add the equations to eliminate for the other variable. So right away, I can see that if I multiply this first equation by 2, I will have 2y. Then if I am to add the 2 equations, the 2 y's will cancel each other out because I have a negative 2 as the coefficient on the second equation. So let's try that. 2 times the first equation would give me 4x plus 2y and equals to 14. And then add that to x minus 2y equals 6. So 4x plus x is 5x, plus 2y minus 2y cancel each other out, and then 14 plus 6 is 20. So then just divide both sides by 5, and we get x equals 4. Now I can just simply plug this into this first equation without the multiplication, the multiply by 2. So if I just plug that in, so I have 2, I know x is 4, so I'll do bracket 4, plus y is equal to 7. So 2 times 4 is 8, I have plus y is equal to 7, and to solve for y, I simply subtract both sides by 8, which would give me y is equal to minus 1. So my final answer would be 4, negative 1. So we're going to use a very similar approach for the 3-equation, 3-variable. So it's very important for you to understand this concept first. So let's move on to some of the steps I'm going to be taking to solve this question. So I have steps 1 through to 6, and I have the equations on the right side of the screen now. And now I would like to give it another try with the background knowledge that you have from the review and also the steps I have provided. So again, another 5-10 minutes, and then come back to the video to check your understanding. So hopefully you've done that. And with that said, let's move on to solving the question. So the first step is to write all of the equations in standard form. And as we know from this chapter, standard form of planes, the equation is ax plus by plus cz plus d. And if I look at all of these, the 3 equations that I have, all of them actually match that criteria, as you can see. So with that said, let's move on to the second step. Our job was just made a little bit easier already because they were in that form. So the second step is arguably the most important step in this whole process. At least that's what I think, because if you understand this step, then the rest of the question will come a lot easier. So the second step asks us to eliminate one of the variables using 2 equations. So that means to choose a variable to eliminate and then multiply the 2 equations so that the coefficients on those variables are opposites. So again, very similar to what we did with the 2-equation, 2-variable system in the review that I just solved. So just by looking at this, I actually noticed that I can multiply this second equation by 2. And once again, I can actually eliminate the y's because I have negative 2y. And if I multiply the second equation by 2, I'm going to have positive 2y. So with that said, I'm just going to add the first and the second equation when I multiply the second equation by 2. So let's give that a shot. I have x minus 2y plus z equals 3 as the first equation. And I'm going to add double the second equation, which would make it 4x plus 2y plus 2z. So I just multiplied all the coefficients by 2, and then the d is going to multiply by 2 as well. So 4 times 2, which is 8. And now I'm going to solve. So x plus 4x is just 5x, minus 2y plus 2y cancels out, and z plus 2z is 3z. And then 3 plus 8 is 11. So that's going to be the first equation that we have solved. So with that out of the way, let's go ahead and move on to step 3, which is repeating step 2, but now with the other equation. And it's very crucial that we eliminate the same variable. So we eliminated y in the first one, and we're going to eliminate y once again. So now that I'm looking at this, so I know that I need to use this equation somehow. And I noticed this first equation is negative 2y, right? And I have 4y on the second one. So if I just multiply this first equation by 2, I would have negative 4y, positive 4y, and then once again, they would cancel out. I'd be left with just x, and z. So let's try that. First, I'm going to multiply the first equation. That would give me 2x minus 4y plus 2z equals 6. And then I would add the third equation as it is. So 3x plus 4y plus 3z equals minus 1. And let's try that. So 2x plus 3x, that's just 5x. Of course, the negative 4 and positive 4y cancel out. And then I have 2z plus 3z, that's 5z. And then 6 minus 1 is just 5. So that's the second equation I have found. And now we can move on to step 4, which is to solve the two variable system using elimination. So I have the two equations that I found out from step 2 and 3. And now by just looking at this, I noticed that, well, we know first thing is we need to add the two equations. So with that said, if I just multiply this equation by negative 1, or rather, I'm going to multiply the second one. So if I just multiply the second one by negative 1, then I would have negative 5x, and I have 5x on the first equation. So because of that, they would just cancel out. So let's do that. But again, this is literally just a two variable, two equation system. So if you notice, the first two steps were just to get to this point, which makes understanding this whole concept a little bit easier, I think. So first I have 5x plus 3z equals 11, and then negative 1 is going to make the second equation negative 5x, negative 5z equals negative 5. So if I solve that, obviously the x's cancel out. 3z minus 5z, that's going to be minus 2z. 11 minus 5 is going to be 6, and then I'm going to divide both sides by negative 2, which would give me z equals negative 3. So we have found the first variable. And now we can move on to step 5, which is using z equals negative 3 to find the other two variables. So I look at the equation from step 2, which had 5x, 3z, and 11. So obviously, I don't know what 5x is. I'm looking for 5x, but now I know what z is. So I can just do plus 3, and instead of z, I'm going to plug in negative 3 equals 11. And now I'm just going to have 5x minus 9 equals 11. So then add 9 to both sides. 5x equals 20. And then divide both sides by 5, which would give me x equals 4. So that's my second variable. And then now I want to look for y. So I have x and z. So I'm going to go back to the original equation number 1 that I had. So I know x is 4, so I'm going to plug in 4 minus 2y. I don't know what y is. That's what we're looking for. And z, which is negative 3. And that is equal to 3. So here I have 4 minus 3, which is 1, minus 2y, just stays, and I have 3 on this side. So subtract 1 on both sides, I would have negative 2y is equal to 2. And divide both sides by negative 2, I would get y is equal to negative 1, of course. So now the final step is to write it as an ordered triplet, which would mean it's going to be 4, negative 1, and negative 3. And I'm going to go ahead and plug this into the three equations to check my answer. For the purposes of the video, I can assure you that they do fit. So I'm just going to do one of them. But once again, I assure you that the other two also work. So x I have 4, and then minus 2, y I have negative 1, plus z, which is negative 3. and that's equal to 3. So 2 times -2 is, of course, -2. And then -3 is just -3. So 4 minus -2 is 2. Sorry, rather 6 and not 2, because it's 4 plus 2. And then the -3 is just -3 equals to 3. So of course, we have the right one. And you can go ahead and try it with the other two equations. But that's our check, and that's the final step. So I have some exercises here for you. I would recommend you to pause the video and really try to solve them by yourself with the steps I have provided on the right. The first system should be very straightforward, very similar to the one I have done. So go ahead and pause the video before I put the solution down. And now that we've done that, hopefully you've gotten the right result. If you haven't, I would encourage you to go back, try to rewatch the video, perhaps go through the steps, try to figure out where you've made your mistake. So the solution for this is -2, 3, 4. All right. So the second system is a little bit more tricky, and the tip I've provided is you don't need to do step 3 here because there are already 2 variable equations. So we don't need to make another 2 variable equation. We just need to make the one and then match it with one of the 3 that we have already we already have in the question. So once again, pause the video. Hopefully you've gotten the right answer. So let's see what the solution to this one is. It is -4, 1, -3. So if you guys have any issues with this, please let us know. I will be more than happy to cover these 2 systems or one of the 2 if you're not able to understand why you made a mistake. So with that said, I am just going to go over and kind of summarize what we went through in the video. So we learned how to solve a 3 variable, 3 equation system through the following steps. So first, you want to write the equation in standard form. Then you want to eliminate one of the variables using 2 equations. So choose a variable to eliminate and then multiply the 2 equations so that the coefficients are exact opposite. So you can get rid of that equation, variable. So you have 2 variables left. And then you want to repeat step 2 with the other equation and eliminate the same variable to create the second 2 variable equation. So, but sometimes, like in the last example, the system 2, in that exercise, we didn't need to do step 3, so be careful with that. So number 4, you want to solve the 2 variable system using elimination. Very straightforward, like the review that we did. And number 5, use the value found from step 4 and solve for the other variables. And step 6, it is to write the solution as an ordered triplet X, Y, Z, and then check with the original equations to make sure you have the right answer. So with step 6, I would also say during a time crunch, so for example, an exam or a midterm, you probably don't need to plug it into every single one. But if you think that you will have enough time to do that and to find to still solve all the other questions, absolutely go ahead and try that. Won't do you any harm. So with that said, I'm gonna thank you for watching this video. Absolutely, I'd say go ahead and subscribe to our YouTube channel if you have any issues with any course really at Ryerson. We'll be more than happy to help. There's tons of resources out there on this YouTube channel. So hopefully you've learned something today. Have a great day.